Today, we're going to dig into a really powerful idea, using the past to see into the future. Specifically, we're looking at how historical data can help us forecast the spread of a disease, turning old patterns into new predictions that can actually save lives. It's a question we've all asked, right? We look for signs, we try to guess what's coming, but what if the best crystal ball we have isn't magic at all? What if it's just data? You see, for something like a virus, its future path isn't totally random. It leaves behind clues, a sort of breadcrumb trail in the data of its own history. And if we can learn to read that trail, we can get a pretty good idea of where it's headed next. Okay, so let's get into it. First things first, we have to really understand the problem we're trying to solve here. So imagine you're a public health official. A virus like dengue is a constant threat. Now, if you knew an outbreak was coming, you could do so much. Prepare hospitals, stockpile medicine, warn the public. But if you're caught by surprise, well, the consequences can be absolutely devastating. This is not just some academic exercise. This is about getting one step ahead of a crisis to save lives. So, the big question is, how do we get that crucial head start? Well, we build a tool. And in our case, that tool is a statistical model. Now, statistical modeling might sound super complicated, but the core idea is pretty simple. Think of a model like a map. It's not the actual city, but it's a simplified guide that uses what we already know to help us figure out where we're going. We feed it the history, apply some math, and it gives us an educated guess about what's just around the corner. And this is a really important idea to grasp. When we're looking for a trend, we could just assume that cases go up by the same amount each year, like walking up a steady, gentle hill. But diseases, they often don't work like that. They accelerate. That's why a model that focuses on the growth rate is so much more powerful. Think of it like hitting a skateboard ramp. The curve gets steeper and you pick up speed. That accelerating curve often paints a much, much more realistic picture of an outbreak. So we've got our challenge and we've got our tool. Now let's walk through the actual process, step by step, of how you make a forecast like this. First, every model needs fuel, and for us, that fuel is data. We're using real annual dengue cases from Karnataka, India, from 2019 all the way through 2023. This is our history book. It's the foundation for everything we're about to build. So you can think of our predictive journey in 3 basic steps. Step 1, we gather the data, which we just did. Step 2, our model crunches those numbers to find that underlying trend, that accelerating skateboard ramp we talked about. And then step 3 is the simplest of all. We just extend that trend line out into the future to create our baseline forecast. But here's something that's absolutely crucial to remember. The future isn't set in stone. It's not a single path. So a good forecast doesn't just give you one answer. It gives you a range of what's possible. This is why we create 3 different scenarios. First, you've got the baseline. That's our most likely guess if things just keep going as they are. Then we imagine a pessimistic scenario. What if things get worse? Maybe it's a warmer year and cases jump 15% higher than the baseline. And finally, we have an optimistic scenario. What if our public health efforts really work and we cut cases by 15%? This gives officials a clear window of what they need to prepare for, from the best case to the worst. And here it is. This is where it all comes together. This table lays out our projections for the next 5 years across all 3 of those potential futures. To really see the full range of what could happen, let's just focus on that final year, 2028. First up, let's look at the worst-case scenario. So in our pessimistic future, cases could shoot up as high as 17,300 by 2028. This is the big red flag. It tells health officials, hey, this is the maximum capacity you might need to handle if things really go south. Now, on the flip side, we have our optimistic projection. Here we're looking at around 12,800 cases. This is the goal, right? This shows what's possible with really effective planning and intervention. Fewer people sick, less strain on everybody. And then, smack in the middle, we have our baseline. It lands right around 15,000 cases. This is the most probable future, the one to anchor all the planning around if the current trend just continues. Looking at these numbers is one thing, and it's fascinating. But the real power of a model like this isn't just in predicting numbers, it's in making things happen. And this is exactly how that data turns into action. When you know this range of possibilities, hospitals can plan their staffing, governments know how to budget their resources, you can time public awareness campaigns for when they'll have the biggest impact. It completely changes the game from just reacting to a crisis to actively preparing for one. The ancient Greek statesman Pericles said it perfectly over 2,000 years ago. The point of all this isn't to have a flawless crystal ball. The goal is to have a tool that helps us build a better, safer, and more prepared future. So that leaves us with one final thought. We've seen how data can help us get ready for a virus. And it really makes you wonder, what other huge challenges, from climate change to the economy, could we face a whole lot better if we just learned to read the clues that the past has already given us?